So thanks again for being here. I'm really happy. As I said, I'm also quite nervous because I'm between so great developers, and this is the first time that I'm giving a talk to such a big conference. So thanks for having me here today. So today we're going to talk about how we can work with state machines in Angular. So first things first, not there, that's here. The agenda for today, why we have this presentation today, then we're going to see what is a finite state machine, what is a Statechart, what is XState, the library that we're going to use in order to create our finite state machines, and how we can create and use them with Angular, when we should use them, and some takeaway notes. So I would like to share my journey to state machines. This is me 3 years ago. Back then I was working in Greece, in a company in Greece, in Athens, in a big enterprise application. And after a while, I started wondering what are the factors that makes our software complex? What are the factors that increase the complexity? So the first thing that I thought, it was something really abstract. I said that, okay, the more modifications that you make in a code base, the more people that you add in a project, then the more complexity you have. And I would say that that was a good excuse for me. I said, okay, it's something like, it's something that you cannot change. Complexity, it's going to be there. But then I started reading a paper from Ben Mosley and Peter Marks. Okay, generally I'm not reading so many papers, but for some reason I started reading this one. And what they try to explain in this paper is what is the complexity of a system? What is the complexity in our code base? And what are the factors that increase the complexity? So what they say is that we say that a system or a code base is complex when we struggle to understand it. And what we try to do most of the time as developers is to understand, to read the source code and to understand it, and to reason about it. And when it comes to understanding, two are the factors that there are two factors that might have impact on it, and these factors are the state and the control. When we say state, we mean all the possible states that we can have in our code base. And what we do most of the times is that we try to explain how our code base works, how these states are connected to each other, instead of what is the intended behavior of our code base. And then you have the control, so the order that things happen. And it's the moment that we act like virtual compilers and we try to understand the flow in our code base. And the mental effort that we have to put on this process grows as long as the code base, the size of the code base grows. And also, it's not only about the complexity in our code base, it's also about the complexity in our development process. And what we want in a team is that we want all the participants to be able to speak the same language. So I had all these things in my mind. From the abstract notion of software entropy, I had some more concrete facts. And then one day in the recommendations on my GitHub account, I saw this library. It's called XState. And for me, I started reading about this library, and I realized that you can create finite state machines in Statecharts in your front-end application. I knew already what a finite state machine is from my university, and so it was one of the moments that you realize that you have something really nice in front of you. So for me, it was like a light bulb moment, because I realized that with the finite state machines, by using the state machines in my front-end application, I would be able to solve the main two problems that I have for the complexity. So I would be able to reduce the mental effort that I had to put in order to understand the state and the control. And also I would have a common language for my team, because everyone can understand a diagram. This is my story to state machines, and this is me. My name is Stefanos Lignos. I'm a front-end developer. I'm not always dressed like this, but only sometimes at work. But one colleague of mine created this photo, and I said, okay, I'm going to use it. You can find some information about me on my website, on my GitHub account, and on my Twitter account. I'm the co-organizer of Angular Athens. We started this meetup in 2017 with my friend Katerina Scribelu. And since our meetups now are online, you can join and you can participate. It would be really nice. The second section for today, what is a finite state machine? I'm going to explain what is a Statechart and what is XState. A small disclaimer here. Generally, I don't believe that you can teach a library through a presentation. This is not my intention. There are better, I don't know, there are people that they can do it better than me. My intention today is to motivate you, to inspire you, in order to apply something that I find really useful, and you can also find really useful for your application. So what is XState? David K. Piano, this is his name on Twitter, is the creator of XState. XState is a library for creating finite state machines and Statecharts. But what is a finite state machine? I'm going to give an example in order to explain this. So I will create a finite state machine. I will explain the life of a programmer as a finite state machine. And as we all know, a developer cannot be in a lot of states during his life. He can code or sleep. So he has a finite number of states. So initially, he can be in a sleeping state. And then when the alarm clock rings, when we have this event, he transitions to an implementing feature state. And then after the push code event, he transitions to the sleeping state. Or if there is a bug found event, then he transitions to a solving bug state. Then when the bug is fixed, he can continue implementing the feature, or he can push the code and transition to the sleeping state. So a finite state machine is nothing more than a directed graph like this one with a finite number of states, with an initial state like the sleeping state. And you can transition from state to state based on some events. The important thing that we have to mention about finite state machines is that you can be only in one state. But what is a state chart? A small history about state charts. David Harrell created the language in 1982. Back then, in the Israel aircraft industries, they were trying to build a fighter aircraft, and they had a lot of teams, a lot of brilliant engineers, but also they had a difficulty to progress with this project. So to make some progress. So they called David Harrell, and he started working with them once per week. And after some discussions that he had with the engineers, he realized that the main problem that they had was that they were not able to express what they had in their minds. They didn't have a proper way to communicate to each other. So he created the language for Statecharts. Now it's a standard since 2015. It's a standard from the W3C organization. And actually, XState is based on this standard. So let's, in the previous example, from the solving bug state and the implementing feature state, we have the same event, the push code event. So what we can do instead is that we can have a parent state, the coding state, and then we can have some nested states. The solving bug and that future state can be nested states. If we do this, then we can have only one transition from the parent state to the sleeping state instead of two. And this might seem not so important on this specific example, but when you have a big project with a huge amount of states and transitions, then the readability of your finite state machine is really important. So a hierarchy is here in order, basically David Harrell introduced the notion of a hierarchy in order to make the finite state machines more readable. For the same reason, he introduced the notion of orthogonality. So imagine that you have another developer that works in parallel with the first developer. And this developer can be in the refactoring state, or he can be in the supporting Internet Explorer 11 bug state. At this moment, we can observe a moment of silence for this developer. Life is not always fair. So with orthogonality, what we want to do is to express all the different combinations that you can have between these independent regions. So we use it in order to make, again, our finite state machine more readable. In a state chart, you can also have guarding transitions. So, for example, you can say that you cannot go to you cannot transition to a specific state if a specific condition hasn't been fulfilled. You can have history nodes. That means that if you have already visited a node, you can start from this node. Delayed events, transitions, and other features. So this is what a finite state machine is and what a Statechart is. So how we can create them. In order to show how we can create a state machine, I'm using this example, this project, the real world example application. And on this project, what you can do is that you can create the same application with different technologies. So there are implementations for the same application with React and Redux, with Angular, with Vue, with Reusable, with AngularNL, TRX, and NX, and the same for the backend. So what I did was to create the same application, part of it basically, today. And what I will try to do in the future is to finish my work. This is a work in progress. So today I will try to create the finite state machine for the authentication process of this application. So we can be in the sign-in page, and then we can also be in the sign up page. And then if I add my username, my mail, and something here, then I get an error. Then if I add the correct password, yeah, I'm in this page. These pages are built with state machines, but as I said, it's a work in progress. All right, so let's see how we can create the authentication process for this application with state machines. The first step is to define the states for our state machine. So in this particular case, the initial state is the unauthorized state, and then we have 5 more states apart from the unauthorized. So if the user tries to sign in, we are in the sign in state. If he tries to sign up, we are in the sign up state. If the user is authorized, then we need the authorized state. And when he tries to update his credentials, we are in the updating state. So the visualization that we have for this primal state machine is really simple as well. So we have only 5 states, and there are no transitions between them, right? So we need to add also the transitions. How we do this? In order to add the transitions, we need to define the events for our state machine. So when we are in the unauthorized state, on the sign-in event, we transition to the sign-in state. When we are, for example, in the authorized state, then on logout, we transition to the unauthorized state. And then after doing this, the visualization contains also the transitions. So, all right. So in a real-world application, apart from the states and the transitions, yeah, basically you need to have to handle some side effects. For example, you need to fetch some data from your API. You need to store something in the local storage. You need to bring something from the local storage. So you need somehow to handle the side effects. And the nice thing with XState is that the mechanism for the side effects is embedded on your state machine. And this is very nice because, for example, in the Redux design pattern, you don't have this. And you need third-party tools in order to implement your side effects. So what we do here, the next step is to define our effects. When it comes to effects, we can have 2 types of them. We can have effects that they return back to your state machine events, and you can have fire and forget effects that they don't return something back to your machine. In this case, what we want to do is to invoke an observable. So we invoke the sign-in observable. We will see the implementation for this observable in a while. And then when the sign-in is successful, we transition back to the authorized state. If the sign-in is failed, the observable returns back a sign-in failure event, and we transition to the unauthorized state. And the implementation for the side effect, it's really simple. So you have the auth service, you do an API request, and then if the API request is successful, you return back to your machine a sign-in success event. If the API request is failed, you return back to your machine a sign-in fail event. All right, so you return some data back to your state machine, but somehow you need to store this data to your state machine, right? So let's see an example, the previous example with the life of a developer. In this case, you need you have the finite number of states. That's okay, but in real life, you also want to store the data, to express the data that it can be potentially infinite. So, for example, here you can have an infinite number of bugs for Internet Explorer 11, right? So you do this with something that is called extended state or context. So back in our example, in our state machine for the authentication process, we have defined the context with the user object and the errors array. And then we can use what we said earlier. We can use fire and forget effects in order to assign the user to the context. So what we do here is that for the user that we got back from the API request, we assign it to the context. And also we can have fire and forget effects when we enter in a state or when we exit a state, for example. So the final visualization, it will be like this. So initially you are unauthorized, and then when you have a sign-in event, you transition to the sign-in state. Then if you have a sign-in success event, you transition to the authorized state. And then with a logout event, you go back to the unauthorized state. Or if, for example, the sign-in the sign-in is failed, you have a sign-in failure event, then you transition to the unauthorized state. So what you can do, by the way, this is the visualizer that comes with XState, and you can define your state machine here. You can save it if you are logged in. So what you can do with this state machine is that you can go back to your business analyst and you can say, okay, this is what I have. Do you want me to change something? Do you want to implement it in a different way? Do we want a different flow? So you can reduce the back and forth communication that you have with your business analyst, right? So what about XState in Angular? It's quite easy to start using XState in Angular. However, what I have seen is that there are not enough examples. There is a common pattern, and in Angular community, we love patterns. There are not helper functions to create a state machine like in Vue or for React, for vue.js and React. Generally, I would say that unfortunately there are more support for React in the library than Angular. But this is why we do this presentation today. It would be nice to extend XState with support for Angular. I will try to do it in the next weeks with, for example, the real-world example, but you can also contribute. And all right, so how we can use it? It's simple, as I said. So what you have to do is to pass as an argument the machine that you have created in the machine method that you have here. And if you do this, you get a stateless enriched version of the finite state machine configuration that you already created. And then if you want to get an instance of this machine, you need to pass the machine in an interpret method, and then you can start your state machine. The service that you get back, the instance that you get back is an observable like object. So you can create an observable from it, and you can start listening to changes in your state machine in your components, for example. But probably we have other requirements. So, for example, we might want, when we refresh the page and when we are authorized and we refresh the page, then we want to start the machine from the authorized state. So we might want to save in the local storage the current state of our state machine, and then when we start the state machine, we start from this state. We do this like this here. And also, what else you can do is to save every time that the state of your state machine changes, you can save it in the local storage. But normally in a real-world application, you have a lot of machines, a lot of state machines, and you don't want to repeat yourself. You don't want to do this thing every time. So what I did is that on the demo for the authentication process, which you can find online, of course, I have created a use machine method. And on this method, you can pass as arguments the configuration for your machine and some options. For example, one option can be if you want the dev tools to be enabled or disabled, or if you want to persist your state every time that you transition to a new state. So here, what I'm doing is that when you have when you want to start, when you have provided in the configuration an initial state, then you start your machine from this state. And then when you have said in the configuration that, okay, I want to persist the current state to local storage, for example, yeah, we do it like this. Or you don't save it and you just return the next state for every transition. There is a helper function. It would be nice to be part of the XState library. It would be nice to be a package of the XState library. For the moment, there are similar functions for vue.js and React. So my intention is to add a function like this also for Angular. And then, since you have created this function, what you have to do in your Angular service is just to use it. So we have the use machine function. We pass as an argument the auth machine config and some an object for your configuration. All right. So when you want to use the state machines, of course, you don't have to do this. Okay, you could implement things even before state machines, but you can ask yourself, is the business logic embedded or spread across your components or your templates? Then with XState, you have one source of truth for the business logic, for the behavior of specific functionality, for example, for a specific feature. It's framework agnostic. So if you have a state machine, if you have already implemented a state machine, then you can migrate it immediately to another framework. And we all know how painful it is to migrate even from angular.js to Angular, for example. The business logic and the behavior is decoupled for the component, so it's easier to be tested. The readability is increased because you don't have to search between all of these components, and it's easier to extend the current functionality for the same reason. You can also ask yourself, do I have a common language in my team? Do I need documentation for the business logic? So everyone can understand the visualization of the state machines. It's just a diagram. we have less back and forth communication between the business analyst and the developers and the QA team, for example. And also, when you create a state machine, automatically you create the documentation for this feature. And the last question, is my code base unpredictable and buggy? So the nice thing with state machines and XState is that when you use it, they force you to think about the solution to a problem upfront. And if you think about it, I have already done this before a lot of times. So we start implementing something without even thought about the solution. So it's so nice that you cannot implement something if you haven't thought about it. And you can prevent edge cases, and of course, edge cases are more visible in your diagram. So I would like to close this presentation with I would like to share my dream. So in my ideal, in my imagination, my ideal development process, the business analyst is responsible to create the state machine to express the intended behavior. Then the developer can get this state machine and can use it in order to implement a particular feature. And also the QA team can start implementing the end-to-end tests. And the test scenarios can be provided automatically from the state machine itself. Because there are algorithms that you can use, and they can extract all the possible paths that you can follow in your state machine. There is a package for this on XState. And so you have a common source of truth for the requirements, for the documentation, for testing, and for development. And for me, this is ideal. I hope one day I will be part of this development process. Thanks a lot for your time. You can find some useful links here. Yeah.
We hope so too, Stefanos. This dream you are describing now is definitely something that sounds like a pretty nice scenario to be developing in, and not only for Angular projects even, but in reality, this scenario is like a dream kind of situation.
Exactly. But also it's like a dream, but also you have it in front of you. I mean, you can start working like this.
It is so within reach. Well, we look forward to seeing the result of your contribution to the project and to XState in general.
Yeah, I will do my best for this.
Well, fantastic. And now we are actually, we are going to welcome everybody that wants to join you for a Q&A session back in Hopin. So all the questions will be taking place there. And we thank you again for being part of AngularNL.
See you there. Thank you.